Välkomna allihopa till Fjärranalysdagarna. Hoppas att alla har hunnit in. Jag heter Göran Bogare, jag kommer från Rymdstyrelsen och det här är 6:e gången som vi gör ett sånt här arrangemang tillsammans med användarmyndigheter. Och även denna gång så gör vi det här i samverkan och ni ser vilka myndigheter vi jobbar tillsammans med, en del har roll-ups, men alla som vi samarbetar med kring det här, det finns angivet på broschyren, programbladet här. Så att vi är en hel programkommitté och det är 6:e gången som vi träffas. Så att det är lite tradition. Det är ett vartannat års arrangemang. Och den här gången handlar det om Copernicus som tema, vilket nu har blivit verklighet. Utan istället har vi Svante Werger här som är kommunikationsdirektör på MSB som ska framföra Helenas inledning. Så att välkommen Svante. Där har vi dig.
Thank you very much. I'll speak English since I know there are some English-speaking guests in this plenary session. As you can see, I'm not Helena Lindberg. I'm not the Director General of the MSB. I'm not the board member of the Swedish National Space Board. My name is Svante Werger. I'm Director of Communications at the MSB. And I have greetings from Helena, who is now went to Skåne late yesterday evening and are there today. And she really looked forward to be here today, and she had prepared to be here both to speak and to listen and to participate in discussions and so on. But due to the current refugee situation, she had to go to Skåne, which is the most southern part of Sweden and which is the part of Sweden which is most affected by the refugee situation, at least at the moment. She will, among other things, have a press briefing together with the Minister of Interior about the plans to build tent camps for refugees in different places. So, greetings from Helena Lindberg. Now to the topic of today. It's really an honor to be here and to have the privilege to wish you all welcome to this conference. MSB is responsible for the work to increase the capabilities in society to prevent and to prepare for all sorts of accidents and disasters. Space-based services are, of course, important for us, and they are becoming more and more important. And you will hear of this in some, or at least in some of the sessions during this conference. I will bring up 3 perspectives in this introduction, and especially pinpoint the one in the middle, which I think is important. The more important these services become, the more important it is that they are that we look about things about their vulnerability and their way to actually work all the time. So the dependencies on satellite services and the developments we see within the space-based infrastructure, how do we look at that? Are we aware of the consequences these dependencies might have in our society, especially if we don't think about vulnerabilities and dependencies in advance? But let us start with some examples of how MSB is a user of satellite services. The free, full and open data policy adopted for the Copernicus program foresees access available to all users for the Sentinel data products. Copernicus provides a unified system through which vast amounts of data are fed into a range of thematic information services designed to benefit the environment, the way we live, humanitarian needs, and support effective policy making for a more sustainable future. The collaboration in Sweden is unique. When the stakeholders, all these agencies, cooperate, we are able to highlight the needs and the benefits of new services at a low cost. And I think this is a really good example of cooperation and collaboration. This is also an example of the possibilities that new space technology can provide. Space-based services is, as you all are aware of, a very important tool to be able to do forecasts, to collect data, and to track the long-term changes in the environment that might become a threat to us. And this information gives us possibility and the advantage to analyze and support community planners. So we take this into account in the planning. MSB is the Swedish point of contact for Copernicus, and Copernicus can provide us with satellite imagery over, for example, areas affected by flooding, which is something that we have to deal with almost every year here in Sweden. We can use satellite imagery to give aid, both here and abroad, and MSB participates in many international operations, where it's crucial for our support and our planning and our operational work. Our operational departments are also frequent users of satellite communications. These enable us to reach personnel who is deployed in disaster areas where all infrastructure might be out of function or unreliable. So basically, satellites and space-based services are very important to us. Now to the other side of the coin, which I know will not be the main topic of this conference, but I think it's always, the MSB's not always, it's important for us to pinpoint that we have to think of this perspective. The more important something is, the more dependent we are on it, the more important it is also to think about the dependencies and the vulnerabilities. We are now so much dependent on space-based services in our everyday lives. One of these dependencies that I would like to raise here today is the position and time, the Global Navigation Satellite Systems, GNSS. Position and time have now become critical factors for many functions in our society, and many systems today are relying on positioning, navigation, and timing data. And loss of these services can cause disruptions in, for example, control systems for water purification systems, some financial systems, operation of the electric grid, and miscellaneous communication systems. There are, as I said, dependencies within the energy transmission and distribution. The grid needs a common time and frequency to uphold its function. In a worst-case scenario, major differences can cause a grid collapse or grid problems. And some national power grids use GNSS to supply the desired time and frequency. The next example, water supply. In the water treatment process, it's important to add the right amount of lye to control the pH level. This control process is highly dependent on time. The space-based infrastructure has great potential and is becoming more available as satellites are getting smaller and cheaper to build. But there are also threats that need to be taken into consideration. These threats can be either natural or antagonistic. A natural threat is space weather, for instance, which is gigantic eruptions of energy from the sun. These eruptions can disrupt or even destroy satellites or their functions. It may also affect ground-based infrastructure problems in power grids, pipelines, aviation, railways, and communication. But not to forget the increasing threat from human antagonists who uses technical devices to disrupt or modify GNSS signals. The image here shows how small these devices can be. Another growing threat is also cyber attacks, where, potentially at least, antagonists can attack the satellite itself. MSB is in the middle of some improvements to use the remote analysis, for instance, images from satellites combined with maps, weather forecasts, and other information regarding accidents. And we have some examples of that from the wildfire in Westmanland last summer. I also think we have a lot that we see can be much better than it worked then. Combining data is a very useful tool, and when you get the overall picture, it will impact the strategies to handle a situation. And then again, even here, time is critical and often more important than the quality of the pictures. So, some concluding remarks. The number of launched satellites will rapidly increase and more space-based services will be available. This will increase our dependency on the space-based infrastructure, but it can also create more redundancy in the systems. So it have both sides of it. There will be new space-based tools for us to measure changes on planet Earth or help us to deal with flooding, wildfires, and other disasters. We need to understand how disruptions of space-based services may impact on our ground-based infrastructure. We need to systematically map dependencies on space-based services. We also need to identify dependencies of exact timing and frequency, and identify the extent to which redundant systems for time and position are used in important public activities. And we have to deal with things that can disrupt those systems, such as jammers, extreme space weather, and colliding space debris. And with those words, I wish you a good conference, with good meetings and exchange of knowledge in the imaginative area where space science and practice meets. Thank you very much.